So, but talking about Fitbits, wouldn't it be great if we could have something that would look at our dogs so we don't have to look at them all the time, and that could register something like itching or shaking? That's what we're going to talk about right now. Here's Leanne West from Georgia Tech.
Hi. Thank you. Hi, everyone. I am going to talk to you today about a disruptive technology for veterinary medicine. So what is a disruptive technology? A disruptive technology is one that changes the way we live, work, and play. And this is not working, by the way. There we go. So as you know, everything we're doing nowadays is connected to your cell phone. Data is being taken everywhere. You take pictures, you stream it. It's in your house, it's on your body, it's everywhere. And so really this is the disruptive technology right now is the Internet of Things. Everything around us is connected. All right, so what percent of people own or would consider buying a wearable technology? Is it less than 5%, 5 to 10%, 20%, or 30%? And the votes are coming in. 30% was the winner here, but actually it's 20%. Which I also found surprising when I was putting this together, because I work in the technology world and every single person I know owns at least one, if not multiple, devices. All right, you recognize them. It's the Fuel Band, it's the Fitbit, maybe the Apple Watch, whatever it is, we all own one. And why do we own them? We own them for health-related reasons. That's the number one reason people have these, is to track health statistics for their body. So it's exercise tracking, medical information tracking, and better eating habits usually. Those are the top three things, the top three reasons why people want to own a wearable technology. All right, so here's another question. Which of the following is not a function of currently available wearables for pets? Is it GPS tracking, heart and respiratory test, scratching behavior, or energy level monitoring? All right, scratching behavior is the winner, and you are correct. Nobody else does that right now. All right, so if we can look, like we just said, there are things that are available for pets right now. It might be heart rate and respiratory rate. It might be activity level. It might be the new Merck system, which has the pet owner input information about their dog who is diabetic. But there's nothing automatic about the Merck one. You have to do that yourself. You can also tell where your pet is sometimes too with these devices. All right, so activity trackers. Y'all are going to get a little science lesson this morning so you can understand how what I'm talking about in the end is different than what's out there right now. Everybody's familiar with activity trackers. It's in your iPhone, it's in your iWatch, it's in all of your mobile devices. And what it does is it just takes a reading about how you move. So when you move, it says, yep, you're moving. So on the activity trackers, low signals would be right here. You can't really see a whole lot of the information in the signal. And then high energy activity levels are right here. So where the graph is really spread out, you get the larger numbers. Those are the times that you're seeing high activity. All right, there's also another thing that's really important when you look at this. Sometimes there's periodic data, things that happen at a regular interval, and sometimes there's random data, so you can't really predict what's going to happen next in the signal. All right, and how you take data matters. So you're looking at the periodic signal like I just said, or this random signal. Here, it also matters how often you take the data. So this might be your signal. The blue line without any dots on it would be your signal. And a low frequency signal means you're taking data at a slower rate. So maybe once every second or once every 10 seconds. And if you do that, depending on your signal, you might actually not see any part of the features of the signal. But for high frequency, that means you're taking data more often. And that way you can actually see all of the features of the signal. It's kind of like your camera. When you have a 1 megapixel camera, you can't catch all of the details like you can with a 10 megapixel camera, right? So that's how you can think about it. All right, and here's some real data from dogs. We have the signal for the system that I'm talking about, the VetTrack sensor, is catching data at all of the blue points. And the other people out there who have wearables for your dogs are taking data at a much lower rate. And so you could see them as the red signal right here. So you can see that what we see has much more information and much more detail than what the red signal sees. Okay, so that's going to make a difference. And this is a little bit hard to see, but you can see this is data from real dogs. We've captured over information from over 500 dogs, 1,500 plus hours of detailed annotation with these dogs with the sensor. And what can you see? So some of what you can see is that there are periodic features under running and scratching, okay? And there are random features in things like shaking and barking. Yeah. Some things are very low activity. You can see eating and lying around, very low activity. And then what's high activity? You can see that shaking and even running and scratching are higher activity levels than other actions. All right, so what we do with the VetTrack sensor is we take multiple levels of data at a high resolution and at a greater frequency. So here now, it's a little bit easier to tell the difference between some of these activities. Before you might have just seen like maybe a little bit of a wavy line, but now you can look at this and you can see that drinking looks different than eating or excreting. You can now tell the difference where you couldn't before. And you can also see the very periodic features of the scratching and shaking, kind of all random. But that's really important. So more data, the more data you take, the better you can do with understanding what's happening. All right, another question. So which one of the following is not a feature of the VetTrack's wearable device? Evaluating effect of treatment for scratching, identify how many minutes per day a pet scratches, detecting abnormal behaviors that pet parents may not observe, or diagnosing the cause of scratching. Exactly, diagnosing the cause of scratching. We don't do that with the sensor. That's left up to the veterinarians. They're the ones who are going to make the decision about why your dog is scratching, what treatment they need, and how to handle it. What the sensor is going to do is tell you whether or not that is working. All right. So here's what we do that makes us a little bit different from everything else that's going on besides just taking data at a higher frequency with more resolution. We actually have developed algorithms using a technology that we developed for the military that will automatically determine the best algorithm for you. So this is called the Georgia Tech Multiple Objective Evolutionary Program. Nobody else has it. We have applied these processes which repeatedly outperform human-derived algorithms. So what this is it's making a machine look at the data and figure out what you're doing, and then it figures out exactly what that algorithm needs to be to make sure that you're seeing what you think you're seeing on the sensor. So here we have a shaking classifier. So we take the data and we look for shaking signals in the data. And you saw before, it's pretty easy to tell shaking from other activities. So we look and we say, okay, all of these signals are shaking, and we take them out of the data pool. And then we pass on the rest of the data. And we go through the different behaviors step by step. So the next thing we're looking for is scratching. Again, it had a very distinctive signal, so we know when we're seeing it. We take all of the signals that have scratching as part of them, classify them as such, pass on the rest of the data, and so forth. So we go through all the different behaviors that the pet could be doing, and we classify those, so we know exactly what they're doing. And then in the end, when we have some data left, we judge it by activity level. Okay, so that's where you get the run, the walk, the rest. And that is what other technologies are doing. They're only doing that last step. They're only looking at the magnitude of the data where they see the big signal, a medium-sized signal, or not very much of a signal. That's all they do. So you can see how what we're doing is really different because we look specifically for all of those other activities and can classify those other activities. So this is just kind of a generic overview of the system. It would be that your dog is wearing a sensor, and that information goes up into the cloud. It lives up there. It can be sent to the vet. It can be sent to the pet owner so you can see what's going on. You can have the vet take action based on what they're seeing. And then the vet can make the the vet can then do whatever they need to do to help your dog, say stop scratching or maybe walk better, whatever it is. So you're really looking at before treatment, your dog's been very active, or maybe they haven't been very active. You take them to the vet. The vet says, we think it's X, and we're going to give you this medication. Let's see how this works for you. And you're going to go home, and then you're going to see all that data afterwards so you can understand whether or not that treatment is working or not. All right, and so actually I talked very quickly, so we have some time left. I don't know if it's appropriate to ask for questions or not, or if you wanted to catch up some time. Okay.
All right, there we go. Thank you very much. Big hand of applause.
Thanks.
So before you start, I have one question. Can you give a little bit about your background, so
Sure.
So people know where you're coming from, because you're an academic, aren't you?
I am.
Okay, great.
So I work at Georgia Tech. I am a research scientist. I work in the Georgia Tech Research Institute, which is the applied research arm of Georgia Tech. So I don't teach classes unless it's a guest lecture. What we do is we build things for people and get those solutions out into the real world. About 90% of what we do is actually for the military. And again, that's what this algorithm development process is based on, a military system that we have developed before.
And it's pretty cool because you have a whole lab that does that.
Mm-hmm. Yeah. We do. We have over 1,500 researchers in the Georgia Tech Research Institute who work on various problems.
Go ahead. Microphone, please.
How does Vettrax handle compulsive licking?
How does it handle licking? So again, that's just another signal that we see. and we can look at the data features and determine that it's licking versus something else, and we can classify it. It does have a distinctive signal.
Great. Anybody else? There's a question. Perfect.
I was just curious when this product will be available for research use and for commercial use with veterinary dermatologists or other veterinarians.
Okay, let me rephrase that question for the rest of the audience. So when will it be available for research use and maybe even for clinical use?
Right. So right now we are doing research with it. We're identifying all the different behaviors right now, understanding what all the different signals look like. As far as commercial use, that's actually a really good question, more for the company who's bringing it forward than it is for me to say.
Sure.
But I do know that they want to bring this out in stages where we might classify some behaviors before others.
Sure. And so there will be some more information coming about this. So I have that question right in my mind, and I'll get back to you. Anybody else? There's a question right here. Perfect.
Hi. Is there much variation between individual patients or individual animals as far as their activity signals?
Yes, so the signals I showed, again, they're from over 500 dogs, so we've kind of taken that into account, whether the dog is kind of large in size, little in size. There is variation per animal. One of the things that we've talked about doing in the future is, if we wanted to get more specific than we are now, is to break up the data per weight sizes so that you can do maybe even a finer differentiation for those animals.
Great. There's one more question. Oh, microphone, please.
I was just wondering, do you think this would be able to tell the difference between seizure activity and itching and other activities there for epileptic dogs who are like on monitoring for different medications?
I'm sorry, can you repeat that?
So
Yeah.
the question was, next to scratching and itching, can you also see things like epileptic insults in dogs that have epilepsy that are on medication, for instance?
Yes, you can differentiate that. Some of the things that we've done with this technology in the past have been looking at Parkinson's patients, which isn't necessarily epileptic, but we have looked at it for epilepsy. We're also looking at it for behavioral issues, severe behavioral issues in children, to determine if they're getting better with the therapy or not. Really anything that you do is going to have some sort of characteristic feature or signal. And so if you can take that and you can get a lot of different sizes and shapes and people and conditions, you can start seeing what the different behaviors look at. So it's really important to have a lot of data, and then you can take that data and you can really differentiate all sorts of things. So yes, you would be able to tell for sure epilepsy.
Sounds pretty cool. So thank you so much.
Yep.
I really appreciate that. Thanks.
Thank you.
Thank you.
Appreciate it.
Thank you, Leanne.